Hello everyone, in this video I will try to give a quick overview of the bachelor thesis topic titled Performance Evaluation of Narrowband IoT Random Access. So let's start by giving an overview or a comparison between Narrowband IoT and LoRa. So both Narrowband IoT and LoRa are low power wide area network candidates. These are the front runners. The LP1 is the kind of network that has long range and has long battery lifetimes. So in 2021, the IoT Analytics has projected that the growth rate anticipated for these type of technologies is around 32% until 2026. And as we can see in this figure that the narrowband IoT is the current leader and at 47%, and LoRa follows at 36%. The distinguishing aspect between LoRa and narrowband IoT is that narrowband IoT works in the licensed band, which means that you have to pay for an operator, or the operator has to pay to the government to have a license to send in the frequency ranges of narrowband IoT. And if you want to have a business running this type of IoT networks, then you will have to have a subscription with the cellular operator. LoRa, on the other hand, works in the unlicensed band, which means that you can, as an individual, buy your equipment, or as a company, startup company, buy the equipment and send over this communication band without needing a license or a right, or without paying a fee or a subscription fee to operate your network. And that's why we can see on the right hand side is that these are two worlds, and if we compare between them, so we can find that the narrowband IoT in green has a better scalability, which means you can have more devices in the network. It has a better latency because it has you can establish a connection, so it's not completely Aloha based like the others, like the other technologies. You can have a big payload length. You can guarantee quality of service. So these are the advantages, let's say, of narrowband IoT compared to LoRa and Sigfox. Sigfox is another candidate for unlicensed band communication, but LoRa is the clear leader in this regard. For the LoRa and the Sigfox, they have better range, they have better coverage, which means the range of communication, and coverage means also the range of communication. They're easier to be deployed and more cost efficient because you don't have to pay a license, and they have a long battery lifetime. We can also see on the left hand side is that in the Middle East and Africa, these technologies are currently at 2%, which means that there is a huge growth potential for both technologies within our region. Let's jump to our project. So our objective of the project, we have a huge or have a big experience here at the network department in the LoRa technology, and we would like now to expand our knowledge, our expertise to the narrowband IoT. So our end objective is to build a simulation model that compares between both technologies, so that we can know what are the real benefits, not just the guessed one like in the report, but the real performance quantitative comparison between LoRa and narrowband IoT. And the starting point would be from the random access point of view, which means that you have some devices, and these devices want to access the network which is shared, and we will be implementing the random access scheme of narrowband IoT. And we would like to evaluate the system throughput, so the data rate we can achieve, and also the network capacity, which is the amount of devices that can be supported within this network. And we plan to build this over a Python simulator. And I will include below this video a link to a couple of papers that give more details or insight about narrowband IoT and also narrowband IoT random access.